All right, let's start off on number 20 here. So for this one, we got to use our long division. We kind of always have to use this if we're dividing by anything other than linear. So in this case, we're dividing by a second power, so we definitely have to use that long division. So we put 9x squared minus x plus 5 right there, and then 3x squared minus 7x right there. And then we always kind of start off here with the first thing inside divided by the first thing outside. And so that's going to come out to 3. So 3 is really part of my answer. I always like to line up my like terms. Now, this also tells me that since these were the same power here, this will actually be my last round of this. So what I need to do is I need to take that 3, multiply it by the front, and then put it underneath. So 3 times 3x squared would be 9x squared. And then 3 times negative 7x would be negative 21x. However, now I need to distribute a negative into there, switching the signs. So then I need to add these down. These cancel out. I get 20x plus 5. And so that is my remainder. And then I would just list that as a remainder here because they just ask you for the quotient and the remainder. So I would say 3 with a remainder of 20x plus 5. All right, next up here, number 36, we need to divide these, but since we're dividing by linear, I would actually just use the synthetic division. So for synthetic division, whenever we have the form x plus 2 or x minus 2, we always change the sign right here. And then I would write this one out up here, just the coefficients. Now, since we're missing powers, we need to put zeros in for every missing power. So I have the 4th power there, 3rd power, 2nd power, 1st power is also 0, and then the 0th power is negative 16. Now I just bring this first number down, then I multiply by whatever is up here, so in this case negative 2 as I go back up. Now I add down and then multiply by negative 2 as I go up. So that same process here, adding down and then multiplying by negative 2 as I go back up, and up with 0. Now whenever we do this, it'll always drop the power by 1, so this will now be the 3rd power, the 2nd power, the 1st power, the 0 power, or just the number, and then the last one's the remainder. So for this one, I would say 1x to the 3rd minus 2x squared plus 4x minus 8. And then I wouldn't even list the remainder since it is 0. All right, next up here, it's asking us to use the remainder theorem to evaluate P of C. So I'm trying to find P of 1/2 here. Now, normally I would plug in that 1/2 for all the x's, but the remainder theorem says that if we just do synthetic division with that number, then the remainder will be the same. So I'm just going to do that. So I'm going to bring down the 2. I'm going to multiply that by 1/2, add that down, multiply it by 1/2, and add that down. So I see my remainder is the last number here is 6, and so that means that P of 1/2 is 6. So instead of plugging it in, I just do the synthetic division, and then whatever I get is the remainder. All right, same idea here for number 44, P of negative 2. Instead of actually plugging it in, I'm just going to do my synthetic division with negative 2 up here. So I do the coefficients here, 6, and then I'm missing the 4th power, and then the next one's a 10. And then we are missing the 2nd power, and then we have a 1 for the 1st power, and then a 1 for the number out back. All right, so now we'll go and do our synthetic division here. So that turns into 6, and then negative 12, and then 24. That'll be 34, negative 68. And let's see, 68 times 2, getting kind of big here. 12, 13, 136, okay. So that'll be 137, and then times 2. Oh wait, that's actually 274. So that'll be a negative 274, and then we add that down, we get negative 273. That's our remainder, and so that is equal to P of negative 2. All right, next up here on number 56, we are going to go ahead and synthetically divide by these numbers right there, and then find the rest of the zeros. So I'm going to start off with the 1/3, and so I would get 3, negative 1, negative 21, negative 11, and 6. So that'll be 3, 1/3 would turn it into 1. And then negative 21 times 1/3 would be negative 7. Negative 18 times 1/3 would be negative 6, and we get the 0 at the end. And then I would just do the negative 2 on the leftovers there as our next step. I'll actually do this in a different color here. And so we dropped it from the 4th power to the 3rd power. And so now I'm going to do it again to these leftovers, and that'll drop it down to the 2nd power. So I get 3, negative 6, positive 12, negative 9, and 18, and 0. And so how I would write this then is, for this one I would write x minus 1/3, and then for this one I would write x plus 2, and then for the leftovers I get 3x squared minus 6x minus 9. Now I noticed that actually we can do a GCF here of a 3, and actually every time this works with a fraction that happens. And so what I always do is I then take that fraction and send it into, or sorry, take that GCF and send it into the fraction. So that becomes 3x minus 1 times x plus 2. And then this one right here, I can just regular factor negative 3, negative 2 would be negative 3 and positive 1. So x minus 3, and then x plus 1. So while they already told me 2 zeros, I would say the other 2 zeros are 3 and negative 1. All right, next one here, I wanted to give us a little hint here. I know it's an odd question, but it said find the remainder when this is divided by x plus 1. So obviously if we're going to actually do the synthetic division, it wouldn't be impossible, but it would be pretty close, because we'd have to go here 6 and then 0, 0, and then we'd have to do like almost or over 400 zeros there until we got to this next one right there. So obviously we don't really want to do that, but instead of that, we can kind of actually do this the other way around. And so what we can do is actually plug in negative 1 for all the x's, and that is always the same as the remainder. We usually use the remainder theorem the other way around, which is if we need to know what happens when we plug in a negative 1, we can just synthetically divide by negative 1. What I'm saying now is if we wanted to know the remainder, we can just plug in the negative 1. Part B would be very similar, except you're going to be plugging in a positive 1.